Now let's talk about immutable and final and the difference between them. So when we say a class is an immutable class, that means once we create an object from this class, we can no longer change the content of this object. The content means the attribute, the instance variable's value. Just like if we create a person object, and we have to set the name, the age, the salary, whatever the fields. Once those fields are set, we no longer be able to change them. So that is an immutable class. Okay. A final keyword can only declare a variable or a reference that could not be reassigned. Okay. So there is a difference there. So immutable is more like to demonstrate, to describe a class, and the final keyword is mainly focused on to declare the attribute of a property of a field. Okay, so for example, if we create a class, okay, so we can call it let's say person. Okay, and in the person we can have a ID, have a name, and probably we can have a like salary, okay, something like this, just for demo. And normally we create a class, we have to set the constructor and the getter setters, something like this. This is a regular Java bean or Pojo. Okay, so for ID we have get, set, and so in the caller, okay, public static main method, we create a person, new person, and we can just set, right? So we can set the ID to 1, and then we can set the ID to 2. Okay? So we can basically set every attribute. So that's why this class is a mutable class. So once we created this object, we can still change the attributes inside this person. Okay, so why do we need an immutable? First of all, it's like once the object is created, you don't want anyone or any code to change your attribute, okay, inside this object. It's because sometimes the hash code equals method is calculated based on those fields. So if you change those fields, it will cause some other data structure malfunctioning. Also, some of the data, once it's created, is not supposed to be changed. Let's see if I pass this person, P, into a method, and in that method it do some manipulations, it will just save to database, and then suddenly somehow inside that method the value got changed. But we don't know that because that method is written by someone else, and after they are done their part, your person got changed, but you don't know. So in that case, the immutable class is very suitable for this kind of scenario. We just prevent the user, okay, from altering the attribute. So then how we can just provide a set get method, okay, no set. Okay, so in this case, now this class is an immutable class. ID, name, salary, there's no way you can change them. Okay, and also all the fields, they have a default value. In this case, we don't have a constructor. That doesn't make sense, right? Because we have to set the field. So we can set the field in the constructor here. Okay, so the constructor, we can have an ID. We can put ID there. Okay, just like 1 name. Okay, and put salary. Okay. Something like this. So then once this person is created, there's no way we can change the ID or name or salary, even though we pass it to some other field, some other method, some other class. They can just read the data out. They cannot write it. So there is a concept called a value object in Java, especially in Java EE projects. So the value object means this object contains only value. You can only read it. You cannot change it. This is the immutable class. For the final keyword, okay, let's see. This object of person is an immutable class, but this P reference, okay, is not immutable, okay, because this is a reference, it's a field, so inside this main object and main method. So we can still do something like this, right? We can still create a new object and then reassign it to this P. Right? So in this case, we changed the reference of the p, but we didn't change the object type, just like string class. Okay. So if we put a final keyword in front of this p, then we cannot reassign this value. You can see there's a compilation error saying that, hey, I cannot assign value to final variable p. So this is because of the final keyword here. Of course, we can put final keyword inside here. Okay. Okay, inside this class. That okay. Make sure that nobody gonna change this ID, name, or salary once they are assigned in the constructor. Okay. So in that case, if we have in the constructor we don't assign them, they will give errors. Right. So you can see if we don't assign the salary, okay, it will complain saying that, hey, this is the final. You didn't initialize this final variable because you cannot change it after the object is created. So either you have to give it like a default value like this, or you have to set it in the constructor. You cannot have a get or have a setter method, right? So that's the difference between final and immutable, right? So even though this class can be final also, right? So even though we have final keyword everywhere inside this class, that doesn't make this class immutable. Okay? Only we don't provide setter. Okay? That will make this class immutable. Of course, for this particular case, all the fields are final, and there's nowhere we can change these finals. Then this, of course, is an immutable class. Okay, but this final keyword in front of class just means you cannot have a subclass of this person class. That's it. So it doesn't prevent you to do this. Right? For the final keyword in front of the class, it doesn't prevent you to do this. So you can still do the create a new object and assign it to this person p, because now this final is used to describe this class, and if a final keyword here, this final keyword is used to describe this reference p. Okay, so that's the difference between immutable and final. And also, there's another thing is, what if we have a collections or reference inside this person? Okay, let's see, we have a have this. We have like maybe address. Okay, we go to new array list. Okay, so in this case, this address could be final. Right? That means we cannot reassign this address to some other new array list, but this array list is always object. Okay, this is just a reference. Let's see if we have a getter for this address. Okay, so we have a getter. Here. Okay. Let's put it here. Okay. And outside this person, okay, and for now you see, oh, there's no getter. There's just only getters, no setter. So this is this, and also they have the default value. So this is an immutable class, but I still can do this. p.getAddress.add. Okay, I can still add stuff into this address. Okay, well, I can still change the address element, because this address now is a reference to a mutable object. Right, array list is a mutable object. So we get the reference of this mutable object, and we can still add new element to it. Okay, so then this will cause a problem, because alright, so even though inside the person you don't have a setter, but inside the array list you have a setter. As long as I can get this array list using this address reference, then you can still change the address. Right, so this is because the person maybe have hash code equals, still use this address to calculate the hash code equals. So that's also break the pattern. So how to fix this one? Okay, the best practice would be, I suggest to always return a copy of this address instead of just return the address itself. Just make a copy. Okay. Make a copy. How to make a copy? We can either do this, like use a collections API, and then we can use this copy method, or if you want to make more clear, you can use this unmodified method. Okay. Unmodifiable list, and we pass this address, okay, to here. Okay, so then this one will return a unmodifiable. So that is to see you cannot call the add and delete method for this one. Okay. But this one here, you can still call it, but when you run it, it will throw you exception, saying that, hey, you cannot add this element. See, this is called unsupported operation exception. Okay, exactly in the line here. Okay. If we just return this address, it won't give you this error. Okay, so we'll just let it pass. Okay, so this is the solution of the reference type. Okay, you can just, this is just for a list, or particularly what if you have something else, like if you have a address class, okay, and you can see you can have a address, okay, just only one address, and then in this case we can still use the getter and get this address and then change this change this object, right? So in that case, same thing, you have to manually do a copy of this address and then return it in the getter, so that even though they can change the value, but they are changing the copy, they're not changing the real address object inside the person class. Okay, so that's it.